in this lecture we'll find out the green area using two different methods. In the drawing we have a quarter circle. A or B is a quarter circle. Inside the quarter circle we have the green quadrilateral AODC, and our mission is to find out the area of the green quadrilateral AODC. In addition, we know that side AC of the quadrilateral is equal to 24 units in its length, side CD equals to 7 units in its length, and this angle ACD equals to 90 degrees. Again, our mission is to find out the area of the green quadrilateral ACOD. So we'll start with the first method. First of all, because of the fact that AOB is a quarter circle, it means that this angle AOB must be equal to 90 degrees. Write it down. Angle AOB equals to 90 degrees. And also point O must be the center of the circle that we can create by completing this quarter circle to a circle. So from the center of the circle, that is to say from point O, we draw perpendicular on chord AC. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC as P. So here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O is the center of the circle. From point O, we draw perpendicular OM to chord AB. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. According to this rule, rule number 11, the perpendicular OM to chord AB also bisects chord AB. That is to say, AM equals to MB. So whenever you draw a perpendicular to a chord, then from the center of the circle, then the perpendicular also bisects the chord. Can you implement rule number 11 in our drawing? Why? Because in our drawing, from the center of the circle, that is to say from point O, we draw perpendicular OP on chord AC. So this angle equals to 90 degrees. This angle also equals to 90 degrees according to our construction. Then according to rule number 11, the perpendicular OP also bisects chord AC. That is to say, AP equals to PC. AP equals to PC, but AC in total equals to 24, therefore each half must be equal to 24 over 2. So AP must be equal to 24 over 2, that is 12. And the second half PC must be also equal to 12 units. Again, AP equals to PC equals to 12 units. It is the implementation of rule number 11 in our drawing. Okay, so in the next step, from point D, we draw perpendicular on PO. Again, from point D, we draw perpendicular on PO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point D and PO is Q. So created here quadrilateral QPCD. Inside this quadrilateral QPCD we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of this fourth angle. In total, the sum of those 4 angles must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Again, in order to complete the sum of the angles in quadrilateral QPCD to 360 degrees, the missing angle here must be equal to 90 degrees. So inside quadrilateral QPCD we have 4 right angles, and therefore we relate to quadrilateral QPCD as a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. That is to say PC equals to QD. But PC is 12, therefore QD must be also equal to 12 units. Likewise, in the seventh angle QPCD, CD must be equal to PQ, but CD is 7, therefore PQ must be also equal to 7 units. We will define the length of line segment QO as X. We will focus on the right triangle OQD. In this right triangle OQD, we define angle ODQ as alpha. So in this right triangle OQD, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is equals to 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in a triangle. So this angle equals to 90 degrees minus alpha, but we define 90 degrees minus alpha as beta, and therefore the missing angle here must be equal to beta what is the size of this angle AOP. Angle AOP equals to 90 degrees minus beta. Again, 90 degrees minus beta must be equal to the missing angle AOP. Angle AOP equals to 90 degrees minus beta. It is 90 degrees minus beta, and beta equals to 90 degrees minus alpha, so we substitute beta by 90 degrees minus alpha. We'll open the brackets here. 90 degrees minus 90 degrees is 0, and minus times minus is plus. So in total, this is expression equals to alpha. So actually found out that angle AOP equals to alpha. The missing angle here, angle AOP equals to alpha. We'll focus on the right triangle APO. On the right triangle APO, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta. Therefore, the missing angle here must be equal to beta. In the next step, we will focus on the right triangle OQD. So I copy the right triangle OQD in a new page, and we will find out the value of tangent alpha in this right triangle OQD. side QD of this right triangle OQD equals to 12 units. OQ equals to X according to our definition. And angle ODQ, this angle equals to alpha. So actually this is the right triangle OQD that I copied from the original drawing. And this right triangle OQD tangents alpha equals to x over 12. Repeat again, this right triangle OQD tangents alpha equals to x over 12. In the next step, I'll copy the right triangle APO, this right triangle APO, the new page, and we find out the value of tangents alpha in this triangle. This is the right triangle APO that I copied from the original drawing. Side AP equals to 12 units. What is the length of side PO? From the drawing it is very easy to see that PO equals to 7 plus x. Again, PO equals to 7 plus x, or x plus 7. So in this right triangle APO, we get that tangents alpha equals to 12 over x plus 7. Repeat again, in this right triangle APO, tangents alpha equals to 12 over x plus 7. So we have two different expressions for the value of tangents alpha. The next step, we create equation number 3. According to equation number 3, tangents alpha according to equation number 1 must be equal to tangents alpha according to equation number 2. Okay. So tangents alpha according to equation number 1 is x over 12, and it must be equal to tangents alpha according to equation number 2. Tangents alpha according to equation number 2 is 12 over x plus 7. Okay, here we'll cross multiply this equation and we get that x times x plus 7 equals to 12 times 12, that is 144. Here we'll open the brackets of this side of the equation number 3 and we get that according to equation number 3, x times x is x squared plus 7x is equals to 144. Here we subtract 144 from this equation and we get that x squared plus 7x minus 144 equals to 0. So this is a quadratic equation. The general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we'll find out the value of x according to the following formula, that x equals to minus b plus minus the square root of b squared plus 4 times ac over 2a. Now our specific quadratic equation, x squared plus 7x minus 144 equals to 0. The coefficient a equals to 1. The coefficient b equals to 7. And finally, the coefficient c equals to minus 144. Now we put the data inside the formula for x and we find out the values of x. I'll remind you that in our drawing, x is the length of this line segment QO. Okay. So in our specific quadratic equation, the value of x will be equal to minus b is 7, so minus b is minus 7, plus minus square root of b squared. B is 7, so b squared is 7 squared, that is 49. Minus 4 times a is 1, times c, that is minus 144, over 2a. A is 1, so 2 times 1 is 2. So here we get that x equals to minus 7 plus minus 4 times minus 144 is 576, and plus 576, and 576 plus 49 is equals to 625. So inside the root we left only with 625 over 2. So actually we get that x equals to minus 7 plus minus the square root of 625 is 25 over 2. So here we will have two solutions that are possible for x. The first solution for x is that x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32, and minus 32 over 2 is minus 16. According to the first solution, the value of x is minus 16. But because of the fact that x is a length, and the length must be a positive number, it is possible that x will be equal to minus 16, that is a negative number, so we cancel the solution, and we left only with the second solution that is possible for x. X equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So found out that x equals to 9 units. That is to say, the length of right segment QO is x, and x equals to 9. Our mission is to find out the area of the green shape. So we'll define the green shape into 3 parts. The first part will be the area of the right green triangle APO. We'll define this area as A1. The second part of this green area will be the area of the right triangle OQD. We define this area as A2. And finally, the third part of this green shape will be the area of rectangle QPCD. We define this area as A3. It is very clear from the drawing that the total area of the green shape must be equal to A1 plus A2 plus A3. So I will write it down. The area of the green shape in total must be equal to A1 plus A2 plus A3. In the next step, we'll calculate each area separately, and then we'll add the 3 areas with each other, and this will be the total area of this green shape. That is the question that we have to answer. So again, A1 is actually the area of the green right triangle APO. So I copy the green right triangle APO in a new page, and find out the area of this green right triangle. AP equals to 12 units. PO equals to x plus 7. X is 9, so in total PO equals to 9 plus 7, that is 16. Repeat again, the area A1 equals to the area of the right triangle APO that I copied here from the original drawing. So the area of this right triangle must be equal to AP times PO over 2. AP times PO over 2. AP is 12 times PO is 16 over 2. 16 over 2 is 8. So in total this expression equals to 8 times 12. That is actually 96. So if we're going to find out that A1 equals to 96 square units. Again, the area of the right triangle APO equals to 96 square units. In the next step, we'll find out the area A2. Again, A2 equals to the area of the right triangle OQD. Therefore, I'll copy the right triangle OQD in a new page, and you'll find out the area of this green right triangle. OQ equals to x, and x is 9, and QD equals to 12. QD equals to 12 units in its length. Repeat again. A2, it is actually the area of this right triangle OQD. The area of this right triangle OQD, it is equals to QO times QD over 2. QO is 9 times QD is 12 over 2. 12 over 2 is 6. So in total, this expression equals to 6 times 9, that is actually 54. So we found out that A2 equals to 54 square units. And finally, we find out the value of A3. A3 is the area of rectangle QPCD. The area of any rectangle is the length of the rectangle times the width. Repeat again. The area of any rectangle is the length of the rectangle times the width. The length of rectangle PCDQ is PC times the width is PQ. Again, the length of the rectangle is PC times the width is PQ. PC equals to 12 and PQ is 7. 12 times 7 is 84. So we found out that A3, that is the area of the rectangle, it is equals to 84 square units. Okay. Repeat again. The area of the green shape, the total area of the green shape is equal to A1 plus A2 plus A3. The area of the green shape equals to A1 plus A2 plus A3. A1 equals to 96, A2 equals to 54, and A3 equals to 84. 96 plus 54, it is 150, and 150 plus 84, it is 234. So we actually found out that the area of the green shape, that is the area that we are looking for in this question, in total it is equals to 234 square units. Repeat again, the area of this green shape equals to 234 square units. We finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we join points A and D together by straight line. By joining points A and D, we created the green right triangle ADC. So I copy the green right triangle ADC or ACD in the new page, and we find out the length of the hypotenuse AD. So actually, this is the right triangle ACD that is going from the original drawing. By PT is the abbreviation for Pythagoras theorem. In this right triangle ACD, according to the Pythagoras theorem, AD square equals to AC square plus CD square. So AD square equals to AC square. AC is 24, therefore AC square is 24 squared, that is 576, plus CD square. CD is 7, therefore CD square is 7 squared, that is 49. So AD square equals to 576 plus 49, is actually 625. Here we take out of this equation and finally we find out that AD equals to the square root of 625, that is actually 25. So the hypotenuse of the right triangle ACD equals to 25 units. The next step, we will do a construction. We will complete this quarter circle to a circle. Again, because of the fact that AOB is a quarter circle, this angle AOB must be equal to 90 degrees. And point O must be the center of this circle that we can create by completing the quarter circle to a circle. Now we will complete this quarter circle to a circle. We completed this quarter circle to a circle. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle. We define the radius of this circle as R. So OA is R. We will extend the radius AO until it touches the circle. We define the touching point of the extended radius AO and the circle as M. So point O is the center of the circle, point M is the point of the circle itself, therefore OM is also the radius of this circle, that is equal to R, according to our definition. So AM is a chord that passes through point O, that is the center of the circle, and any chord that passes through the center of the circle must be the diameter of the circle. Therefore AM is the diameter of the circle. And what is the length of AM? AM equals to AO, that is R, plus OM, that is R, so AM in total equals to 2R. In conclusion, we found out that AM is the diameter of the circle, that is equal to 2R. Okay. In the next step, we will extend side CD by a straight line until it touches the circle. And we will assume that the extended side CD will not touch the circle at point M, but in any other point. For example, we assume that the extended side CD will touch the circle at this point, point N. Okay. We know that angle ACN equals to 90 degrees because it is given us in the question that angle ACD equals to 90 degrees. Therefore, when we extend side CD and it touches the circle at point N, it means that angle ACN, the peripheral angle ACN, it is equal to 90 degrees. But it is impossible that peripheral angle ACN will be equal to 90 degrees because it contradicts rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. MN is the diameter of the circle. Peripheral angle MAN equals to 90 degrees, and indeed this peripheral angle MAN is equal to 90 degrees. It rests on MN, it is the diameter of the circle. And because of the fact that peripheral angle ACN also equals to 90 degrees according to what is given us the question here, it means that according to rule number 9, this peripheral angle ACN must rest on AM, that is the diameter of the circle. But according to our assumption that the extended side CD will touch the circle at point N, it means that peripheral angle ACN is equal to 90 degrees is rest on chord AN, that is not the diameter of the circle. It contradicts rule number 5, because according to rule number 5, peripheral angle, this peripheral angle is equal to 90 degrees must rest on AM and not on AN. Okay? So, because of the fact that due to our assumption that the extended side CD will touch the circle at point N, we have a contradiction, because according to rule number 5, it must rest on AM and not on AM, that is the diameter of the circle, and not on AN. Therefore, our assumption that the extended side CD will touch the circle at point N is not correct, and therefore we have to conclude from it that the extended side CD must touch the circle at point M and not in any other point. And now we don't have any contradiction at all to rule number 5. Why? Because we have peripheral angle ACM that is equal to 90 degrees. And this peripheral angle ACM rests on AM, that is the diameter of the circle. So in order to avoid the contradiction to rule number 5, we must conclude that the extended side CD will touch the circle at point M and not in any other point. And then we will have peripheral angle ACM that is equal to 90 degrees, and this peripheral angle that is equal to 90 degrees rests on AM, that is the diameter of the circle, exactly according to rule number 5. Okay, so here CDM is one straight line because we extended side CD by straight line, and the result is CM. Therefore, CDM in total it is one straight line. In the next step, we will focus on this side of the straight line AM at point O. Which angles we have at this side of AM at point O? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So the missing angle there must be equal to 90 degrees. In the next step, we prove that the green right triangle AOD is congruent to the green to the white right triangle MOD. Repeat again, the green right triangle AOD is congruent to the white right triangle MOD. So why those two right triangles congruent to each other? First of all, mu equals to OM. Repeat again, side AO on the red triangle equals to side OM in the white triangle. They are the area of the circle, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle AOD in the red triangle equals to angle MOD in the white triangle. Okay, again, angle AOD in the red triangle equals to angle MOD in the white triangle. They are both equal to 90 degrees, therefore they are equal to each other. And finally, this angle and this side, side DO, is a common side that belongs to both triangles. So side DO equals to itself as a common side that belongs to both triangles. This again, side DO equals to itself as a common side that belongs to both triangles. So we actually proved that the green right triangle AOD is congruent. This is the sign of congruent to the white right triangle MOD according to side angle side rule. That is to say, those two sides and the angle between them in the green triangle are correspondingly congruent to those two sides and the angle between them in the white triangle. Therefore, we actually prove that those two right triangles congruent to each other according to side angle side rule. And from the fact that those two right triangles congruent to each other, we conclude that AD equals to DM. Side AD of the green triangle equals to side DM in the white triangle. AD equals to DM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding sides AD and DM must be also equal to each other. But AD equals to 25 units. So you can write here that AD equals to 25. And from this equation, 25 equals to AD equals to DM, we will derive that DM is also equal to 25 units in its length. Here this side DM equals to 25 units. I've already said that CDM is one straight line. If CDM is one straight line, then CM must be equal to CD plus DM. That is to say, CM equals to CD, that is 7, plus DM, that is 25. So in total, CM equals to 7 plus 25, that is 32. The length for side CM in total equals to 32 units. So we copy the right triangle ACM in the new page and we'll implement the Pythagoras theorem on this right triangle ACM. So actually, this is the right triangle ECM that I copied from the original drawing. AC equals to 24 units in its length, according to what is given us the question. We just right now found out that the length of side CM is 32 units. And finally, the hypotenuse AM is the diameter of the circle. Is equals to 2r. Here by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, on this right triangle ACM, we'll get that AM squared equals to AC squared plus CM squared. So AM equals to 2r, therefore AM squared is 4r squared is equals to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576 plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. So 4r squared equals to 576 plus 1024, that is equal to 1600. So 4r squared equals to 1600. We divide this equation by 4 and finally we get that r squared equals to 1600 over 4 is 400. We take out of this equation and finally we get that r equals to the square root of 400, that is 20. So the radius of the circle r is equals to 20 units. In the next step, I will copy the right triangle AOD in the new page and we'll implement the Pythagoras theorem on this right triangle AOD in order to find out the missing side OD. So actually this is the right triangle that I copied from the original drawing. AO is the radius of the circle that is equal to 20 units. AD, the hypotenuse AD equals to 25 units. By PT is a relation for Pythagoras theorem. In this right triangle AOD, we get that according to the Pythagoras theorem, AD squared equals to AO squared plus OD squared. AD equals to 25, therefore AD squared is 25 squared, that is 625 plus AO squared. It is equals to AO squared. AO is 20, therefore AO squared is 20 squared, that is 400 plus OD squared. OD is the missing side, so we leave it as it is. We subtract 400 from this equation and we get that 625 plus 400 is 225. That is equals to OD squared. Here we take a root out of this equation and finally we get that OD equals to the square root of 225, that is 15. So here we found out that the missing side here, side OD, is equals to 15 units in its length. We are looking for the area of this green shape. We will divide the green shape into two parts and we calculate the area of each part and then we add the two parts together, the two areas together. This will be the area of the green shape. So the area of the green shape in total will be equal to the area of the right triangle AOD that we define as A1 plus the area of the green right triangle ACD that we will define as A2. It's very clear from the drawing that the total area of the green shape equals to A1 plus A2. A1 is the area of the right triangle AOD plus A2, that is the area of the right green triangle ACD. So write it down. The area of the green shape in total must be equal to A1 plus A2. So A1 is the area of the right triangle AOD, so I copy the right triangle AOD in a new page and we find out the area of this right green triangle. So this is the green right triangle that I copied from the original drawing. So here, the area of this right triangle will be equal to AO times OD over 2. AO is 20 times OD is 15 over 2. 20 times 15 is 300 and 300 over 2 is 150. So we conclude found out that A1, that is the area of this right triangle, equals to 150 square units. In the next step we find out the value of A2, that is the area of the green right triangle ACD. So I copy the green right triangle ACD in a new page and we find out the area of this green right triangle. So this is the green right triangle ACD that I copied from the original drawing, and the area of this right triangle it is the value of A2. The area of this right triangle is equals to AC times CD over 2. AC times CD over 2. AC is 24 times CD is 7 over 2. 24 over 2 is 12, so in total this expression equals to 12 times 7, that is 84. So we found out actually that A2 equals to 84 square units, and we have already found out that A1 equals to 150 square units, and the total area of the green shape is equals to A1 plus A2. That is to say, it is equals to A1, that is 150, plus A2, that is 84. 84 plus 150, in total it is equals to 234. So we found out that the area of the green shape, according to the second method also, is equals to 234 square units. Okay. The next step, I'll summarize the lecture. We start with the first method. So in this lecture we found out the area of this green shape. It is actually quadrilateral AC or D. In the drawing we have a quarter circle, A or B is a quarter circle, and in addition you know that side AC of the quadrilateral A or DC is equal to 24 units in length, side CD equals to 7 units, and this angle ACD equals to 90 degrees. Again, our mission is to find out the area of the green quadrilateral AODC. Okay, so because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees, and point O is the center of the circle that we can create by completing the quarter circle to a circle. Okay, so from point O, that is the center of the circle, we draw perpendicular on AC, on chord AC. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the starting point of the perpendicular from point O and AC as P. And here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O is the center of the circle. From point O, we draw perpendicular OM on AB, on chord AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. According to this rule number 11, the perpendicular OM is not only perpendicular to AB, but it also bisects chord AB. That is to say, AM equals to MB. Again, any perpendicular from the center of the circle to a chord will also bisect the chord. In this case, AM equals to MB. The perpendicular OM bisects chord AB. That is to say, AM equals to MB. We can implement rule number 11 in our drawing. Why? Because in our drawing, point O is the center of the circle. From point O, we draw perpendicular OP on chord AC. According to rule number 11, the perpendicular OP on chord AC also bisects chord AC. That is to say, AP equals to PC. Okay, but AC in total is 34, therefore each half will be equal to 24 over 2. That is to say, AP will be equal to 24 over 2, that is 12, and PC must be also equal to 12 units according to rule number 11. So AP equals to PC equals to 12. This is actually the implementation of rule number 11 in our drawing. Then from point D we draw perpendicular on PO. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. In this way we created here quadrilateral PCQD. Inside this quadrilateral PCQD we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees. Here we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees plus this missing angle. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. So inside quadrilateral PCQD we have 4 right angles. Therefore, we can relate to quadrilateral PCQD as a rectangle and know that the opposite sides of a rectangle are equal to each other. That is to say, CD equals to PQ. But CD is 7, therefore PQ must be also equal to 7. In the same rectangle, PC must be also equal to the opposite side QD. but PC is 12, therefore QD must be also equal to 12 units in its length. Then we defined the length of this line segment QO as X, and we focus on the right triangle OQD. So I copied the right triangle OQD here. This is the right triangle OQD that I copied from the original drawing. Side OQ equals to X according to our definition, and QD equals to 12 units. We defined angle QDO as alpha. This is angle alpha, and QD equals to 12. In this right triangle QOD, tangent alpha equals to X over 12. Again, tangent alpha equals to X over 12. Then I copied the right green triangle APO here in the new page, and I found out the value of tangent alpha in this right triangle APO. This is the right triangle APO that I copied from the original drawing. Side AP equals to 12 units in itself. And what is the value of PO? In total, it is very easy to see from the drawing that PO equals to 7 plus X. Okay? PO equals to 7 plus X, and this is angle alpha. Actually, because of the fact that we define this angle as alpha, this angle equals to 90 degrees, therefore the missing angle A must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. So this angle equals to 90 degrees minus alpha. But we defined 90 degrees minus alpha is beta, therefore this angle equals to beta. Then what is the value of this angle AOP? Angle AOP must be equal to 90 degrees minus beta. Again, 90 degrees minus beta must be equal to the missing angle AOP. So angle AOP equals to 90 degrees minus beta. Beta is 90 degrees minus alpha, therefore we can substitute beta by 90 degrees minus alpha. Then we open the brackets here. 90 degrees minus 90 degrees is 0, and minus times minus is plus. So in total this expression equals to alpha. So we found out the missing angle here, AOP, it is equal to alpha. So this is the missing angle AOP that is equal to alpha. PO equals to X plus 7, and AP equals to 12 units. In this right triangle AOP, we get the tangent alpha equals to 12 over X over 7. Tangent alpha equals to 12 over X plus 7. Again, tangent alpha in this right triangle equals to 12 over X plus 7. So we have two different expressions for tangent alpha. In the next step, we created equation number 3 that states the tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 1 is X over 12, and it must be equal to tangent alpha according to equation number 2, that is actually 12 over X plus 7. Because we multiplied this equation, we found out that X times X plus 7 equals to 12 times 12, that is 144. We open the brackets on this side of the equation and found out that X times X is X squared plus 7X, that is equals to 144. We subtracted 144 from this equation and found out that X squared plus 7X minus 144 equals to 0. So we have a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. We will find out the value of x according to the following formula: x equals to minus 3 plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, x squared plus 7x minus 144 equals to 0, the coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. Then we put the data inside the equation in order to find out the value of x. I remind you that x, according to our definition, is the length of line segment QO. So we put the data inside this equation in order to find out the value of x. X equals to minus b, b is 7, so minus b is minus 7, plus minus square root of b squared. B is 7, so b squared is 7 squared, that is 49. Minus 4 times a is 1, times c is minus 144. minus 4 minus 144 is plus 576, plus 576 plus 49. In total, it is equals to 625. So under the root, inside the root, we left only with 625. So in conclusion, we found out that x equals to minus 7 plus minus square root of 625 over 2. Okay, and so actually x equals to minus 7 plus minus the square root of 625 is 25 over 2. So here we will have two solutions that are possible for x. The first solution is that x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32, and minus 32 over 2 is minus 16. So in conclusion, according to the first solution for x, we found out that x equals to minus 16. But because of the fact that x is the length, and the length must be a positive number, therefore it is impossible that x equals to minus 16, that is a negative number. So we left only with the second solution, that it's possible for x. X could be also equal to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So conclusion found out that x, that is the length of this line segment QO, equals to 9 units. So in the next step, we divided the green area into 3 parts. The first part is the area of the green right triangle APO, that we define as A1. The second part is the area of the green right triangle QOD that we defined as A2. And the third part is the area of rectangle PQDC that we defined as A3. In the next step, we calculated each part, the area of each part separately, and then we added the 3 parts together. It is very clear from the drawing that the total area of the green shape must be equal to A1 plus A2 plus A3. So A1 is the area of the right green triangle APO. So I copied the right green triangle APO in a new page in order to find out the area of this green right triangle. A1 is the area of the right triangle APO. So I copied the right triangle here from the original drawing. AP equals to 12. And PO equals to x plus 7. X is 9, so x plus 7 is 7 plus 9, that is 16. The area APO of this right triangle is AP times PO over 2. AP is 12, PO is 16 over 2. 16 over 2 is 8, and 8 times 12 is 96. So in conclusion, found out that A1, that is the area of this right triangle, equals to 96 square units. Then we found out the area of A2. A2 is the area of the right triangle QD. QD equals to 12 units in itself, and QO equals to x, that is 9. The area A2, that is actually the area of this right triangle QD, equals to QD times QO over 2. QD is 12 and QO is 9, so 9 times 12 over 2. 12 over 2 is 6, so in total this expression equals to 6 times 9, that is 54. So we found out in conclusion that the area QOD of this right triangle equals to 54 square units. And finally, we calculated the area of A3, that is the area of rectangle PCQD. The area of any rectangle equals to the length of the rectangle times the width. The length is PC, that is 12, times the width is PQ, that is 7. So in total the area equals to 12 times 7, that is 84. So the area of rectangle BCQD equals to 84 square units. And the total area of this green shape equals to A1 plus A2 plus A3. I will repeat again, the total area of the green shape equals to A1 plus A2 plus A3. A1 is 96, A2 is 54, plus A3, that is 84. 96 plus 54 is 150, 150 plus 84 is equal in total to 234 square units. In conclusion, found out that the area of this ring shape equals to 234 square units. We finished with the first method, then I presented to you how to find out the area of this ring shape according to the second method. In the second method, we join points A and D together by a straight line. In this way, we created the grand right triangle ACD. So I copied the grand right triangle ACD and found out the length of the hypotenuse AD. This is the right grand triangle ACD that I copied from the original drawing. AC equals to 24 and CD equals to 7 units according to what is given as the question. According to the Pythagoras theorem, in this right triangle ACD, AD square equals to AC square plus CD square. So AD square equals to AC square. AC is 24, therefore AC square is 24 squared, that is 576 plus CD square. CD is 7, therefore CD square is 7 squared, that is 49. So in total, AD square equals to 576 plus 49, it is 625. So AD square equals to 625. We took out of this equation, we found out that AD equals to the square root of 625, that is 25. So the hypotenuse AD here of the right triangle ACD equals to 25 units in its length. Then we completed this quarter circle to a circle, but because of the fact that AOB is a quarter circle, it means that this angle equals to 90 degrees, and point O is the center of the circle that we can create by completing the quarter circle to a circle. We actually completed this quarter circle to a circle, and point O is the center of this circle, point A is the point of the circle itself. This is exactly the definition of a radius. So OA is the radius of the circle that we defined as R. Then we extended the radius AO by a straight line until it touches the circle at point M. We define the touching point of the extended radius AO of the circle as M. Again, point O is the center of the circle, point M is the point of the circle itself, therefore OM is also the radius of the circle that is equals to R. So OM is one straight line because we extended the radius AO by straight line, and the result is AM. When we extend a straight line by straight line, in total we will get a straight line. So AM is a straight line that touches the circle at points A and M, and therefore AM is a chord that passes for point O, that is the center of the circle. Any chord that passes for the center of the circle must be the diameter of the circle. Therefore AM is the diameter of the circle. What is the length of chord AM? AM equals to R plus R, that is 2R. So in conclusion, you can say that AM is the diameter of the circle, that is equal to 2R. 2 times the radius of the circle. Then we extended side CD by straight line until it touches the circle. The real question is, well, the extended side CD will touch the circle. We will assume that the extended side CD will touch the circle at point N, and not at point M. But then we will have contradiction to rule number 5. One, because we have here peripheral angle ACN that is equal to 90 degrees according to what is given as the question, and still this peripheral angle ACN that is equal to 90 degrees, it doesn't rest on AM, that is the diameter of the circle, but on AM, that is not the diameter of the circle. And it contradicts rule number 5. Why? Because according to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter AM and not on AM, that is not the diameter. But according to our assumption that the extended side CD will touch the circle at point N, then the peripheral angle ACN will not rest on AM, that is the diameter of the circle, but on AN, that is not the diameter of the circle. Contradicts rule number 5. According to this rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. If peripheral angle MAN equals to 90 degrees and it rests on MN, that is the diameter of the circle. And therefore, it is impossible that peripheral angle ACN is equal to 90 degrees, we rest on AN, because AN is not the diameter of the circle. Okay, so due to our assumption that the extended side CD will touch the circle at point N, we have contradiction to rule number 5. Therefore, we must conclude that our assumption that the extended side CD will touch the circle at point N is not correct. And therefore, the extended side CD must touch the circle at point M and not in any other point. And then we will avoid the contradiction to rule number 5. Why? Because if the extended side CD will touch the circle at point M, then we will have a peripheral angle ACM that is equal to 90 degrees. And indeed, this peripheral angle ACM that is equal to 90 degrees, it rests on AM that is the diameter of the circle, exactly according to rule number 5. And therefore, CDM is one straight line. Then we focus on this side of the straight line AM at point O. Which angles we have at this side of AM at point O? We have this angle plus the missing angle. In total, it must be equal to 180 degrees, according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. So 90 degrees plus the missing angle, it must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees. Then we proved that the green right triangle AODs can go into the white right triangle ODM. Why those two right triangles can go into each other? First of all, AO equals to OM. Side AO of the green triangle equals to side OM of the white triangle. They are both the area of the circle, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle AOD in the green triangle equals to angle MOD in the white triangle, they are both equal to 90 degrees, therefore they are equal to each other. And finally, this side DO is a common side that belongs to both triangles, so this side equals to itself. DO equals to itself is a common side that belongs to both triangles. So we actually proved that those two right triangles can go into each other according to side angle side rule. That is to say, those two sides and the angle between them in the green triangle are correspondingly can go into those two sides and the angle between them in the white triangle. Therefore, those two right triangles can go into each other according to side angle side rule. And for the fact that those two right triangles can go into each other, we will derive that AD equals to DM. AD equals to DM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides, that is to say AD and DM, must be also equal to each other. But AD equals to 25. Here we can write down that AD equals to 25, and for this equation 25 equals to AD equals to DM, we will derive that DM also equals to 25 units. This side DM equals to 25 units. Therefore, in total, the length of side CM is CD plus DM, because CDM is one side line. CD plus CM is 7 plus 25, that is 32. So in total, CM equals to 32 units, AC equals to 24, and AM is the diameter of the circle that is equal to 2R. So I copied the right triangle ACM in a new page and implemented in this right triangle the Pythagoras theorem. This is the right triangle ACM that I copied from the original domain, and repeat again. This is the right triangle ACM that I copied from the original domain. AC equals to 24, CM equals to 32, and AM is the diameter of the circle that is equal to 2R. According to the Pythagoras theorem, in this right triangle ACM, AM squared equals to AC squared plus CM squared. AM squared equals to AC squared plus CM squared. AM is 2R, so AM squared is 2R squared, that is 4R squared. And it is equal to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576, plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. So in conclusion, found out that 4R squared equals to 576 plus 1024, that is 1600. So 4r squared equals to 1600. We divided this equation by 4 and we got that 1600 over 4 is 400. So r squared equals to 400. We took out of this equation and finally found out that r equals to the square root of 400, that is 20. The radius of the circle r equals to 20 units. Then I copied the right green triangle AOD in a new page in order to implement on this right triangle the Pythagoras theorem in order to find out the missing side OD. This is the right triangle AOD that I copied from the original drawing. AO is the radius of the second is equal to 20 units, the opponent AD equals to 25 units. So in this right triangle AOD, according to the Pythagoras theorem, AD squared equals to AO squared plus OD squared. AD squared equals to AO squared plus OD squared. So AD is 25, therefore AD squared is 25 squared, that is 625. And it is equal to AO squared. AO is 20, therefore AO squared is 20 squared, that is 400 plus OD squared. We subtracted 400 from this equation and finally found out that OD squared equals to 625 plus 400 is 225. So OD squared equals to 225. We took out of this equation and finally found out that OD equals to the square root of 225. That is 15. So the missing side here, OD equals to 15 units in its length. Yeah, OD equals to 15 units in its length. Our mission is to find out the area of this green shape. We divided this green shape into two parts. The first part is the area of the right green triangle AOD that we define as A1. The second part is the area of the right green triangle ACD that we defined as A2. It is very clear from the drawing that the total area of the green shape equals to A1 plus A2, that is the sum of the areas of those two right triangles, AOD and ACD. Here, the area of the green shape equals to A1 plus A2. A1 is the area of the green right triangle AOD, so I copied the triangle AOD here in a new page. AO equals to 20, OD equals to 15. So the area of this right triangle AOD equals to AO times OD over 2. AO is 20, OD is 15, divided by 2. 20 times 15 is 300, and 300 over 2 is 150. So in total, the area of the right triangle AOD is 150 square units, plus A2. A2 is the area of the right green triangle ACD. So copy the right green triangle ACD here. AC equals to 24, CD equals to 7. So A2 is the area of this right triangle ACD. The area of this right triangle ACD equals to AC times CD over 2. AC is 24, CD is 7 over 2. 24 over 2 is 12. So in total, this expression equals to 12 times 7, that is 84. So actually found out that A2 is equals to the area of this right triangle ACD, that is actually 12 times 7 is 84 square units. So A2 equals to 84 square units, and we have already found out that A1 equals to 150 square units. And the area of this green shape equals to A1 plus A2. A1 is 150 and A2 is 84. So the total area of the green shape equals to 150 plus 84, that is 234 square units. Repeat again, the area of this green triangle according to the second method also is equals to 234 square units. Okay, thank you very much.